Hello everyone. In this video, we will try to find the solution of a problem which says a turn of radius 20 meter is banked for the vehicles going at a speed of 36 km per hour. If the coefficient of static friction between the road and the tire is 0.4, what are the possible speed of a vehicle so that it neither slips down nor skids up? Let's say this is the angle theta of the slope of this road and this is the car going on the banked road, right? So at this particular scenario, the mg force will act in the downward direction. The mv square by r centrifugal force will act outward direction. If this is angle theta, then this angle will also be theta. So that means there will be two component of the centrifugal force. One is mv square by r cos theta and mv square by r sin theta. If this is theta, then this angle will also be theta. So the mg component will be mg cos theta and here it is going to be mg sin theta. The normal force will act on the upward direction, right? So now there will be two scenarios. One is if the speed is exceeding in such a way that the mv square by r cos theta component is greater than mg sin theta, then the car will try to move in the outward direction. So in that case, the friction will act in the downward direction, right? So in that particular scenario, so that the car should not move from this position, so in that case, we can write the frictional force or the required friction should be equal to mv square by r cos theta minus mg sin theta. So this is the required friction to move this car safely on this banked road, right? Now, the maximum available friction on this tire and the bank road will be mu into n, right? So this is the friction which is maximum available. Now, so n from this diagram, we can simply say n is equal to mv square by r sin theta plus mg cos theta. Now F max or the maximum available friction is mu times mv square by r sin theta mg cos theta, right? So to safely drive this car, F required should be less than equal to F maximum available, right? So in this case, mv square by r cos theta minus mg sin theta should be less than equal to mu times mv square by r sin theta plus mg cos theta. Now throughout m will cancel out and let's rewrite it as mv square by r cos theta minus mu sin theta should be less than equal to mu times g cos theta plus g sin theta. Now the value of v will become under the root mu r g cos theta plus mu g sin theta upon cos theta minus mu sin theta. Further we will write it as rg as a common and I am just taking cos theta is also common, so that will become 1 plus mu tan theta upon 1 minus mu tan theta, right? So this is the maximum velocity which we can give this car so that it can safely move along this banked road. Now similarly, we can also get the V minimum. So in that scenario, the friction will act in the upward direction because the car will try to move in the downward direction. So that is going to be the minimum velocity which we should give this car so that it should not slides down, right? To get that, we will write all the equation in a similar way, but there is only one difference, which is F required will be mg sin theta minus mv square by r cos theta. Again, we will write the same equation. So f max will remain same in both the scenarios. So if we compare the mu n with f required, so we will get f required should be less than equal to f max. Again, in this scenario, mg sin theta minus mv square by r cos theta should be less than equal to mu times mv square by r sin theta plus mg cos theta, right? So if we solve that, we will get v is equal to under root rg times sin theta minus mu cos theta upon mu sin theta plus cos theta. So we can also rewrite it in the terms of tan theta. So this is going to be rg times tan theta minus mu upon mu tan theta plus 1. So for this question, we can directly remember these two equations, which are very helpful. Now, I told you like how we have wrote this equation. Now we can simply apply this equation in this particular question, which says the radius of the track is given as 20 meter. Mu is 0.4. Theta we will calculate using the equation v is equal to under root r g tan theta, because this is the velocity when there is no friction. So this is the theta we can get when there is no friction at all, right? So tan theta will become v square upon rg. The value of v is 36 km per hour. That means 10 meter per second, right? So if we feed this value here, so v square is 100 upon r is 20 into g is 10. So this will become 1 by 2. So tan theta value is 1 by 2. So using all these value in above equations, so v minimum is under root rg tan theta minus mu upon mu times tan theta plus 1. So we will feed the values here. R is 20, G is 10, tan theta is 0.5 minus 0.4 upon 0.4 into 0.5 plus 1. Further, this will become under the root 20 into 10 into 0.1 upon this will become 1.2. So further, this is going to be 4.08 meter per second, or we can say 4.08 into 18 by 5. So this will become 14.7 kilometer per hour. Now to get the maximum value, which is V max, the formula is under root Rg times 1 plus mu tan theta upon 1 minus mu tan theta. Now this further will become under root R is 20, G is 10 times 1 plus 0.4 into 0.5 upon 1 minus 0.4 into 0.5. So if we further solve this, under root 225 or 15 meter per second. So to convert this into kilometer per hour, 15 into 18 by 5, so that will become 54 kilometer per hour. So this is the solution of this problem.